Solve each quadratic equation using the square root property. Give exact answers and approximate answers rounded to 2 decimal places. Check the answers in the original equation. Now the square root property tells us that if we have x squared equal to a number, then x is equal to plus or minus square root of a. Well, in this case we don't have just a variable, but we have some variable quantity that's being squared. Well, instead of having an x squared, I could say the same thing if I just had, well, if box square is equal to a, then box is equal to plus or minus square root of a. So the x is just a placeholder. And now in this example, what's in the box is n plus 1 rather than just a variable. So I can apply the same concept. If I have n plus 1 squared equal to 49, then n plus 1 would equal plus or minus square root 49. So then n plus 1 is equal to plus or minus 7. Now generally what we want to do here is break this up into two equations. So n plus 1 is equal to negative 7, or n plus 1 is equal to positive 7. Now we solve each of these equations. I'll just subtract 1 from both sides on the first equation, subtract 1 from both sides on the second equation, and so that would give me n equals negative 8, n equals 6. Let's check these solutions. I'll check negative 8 first. So let's see, negative 8 plus 1 squared, is this equal to 49? Negative 8 plus 1 is negative 7. Negative 7 squared is 49. That checks out. Now checking the 6. 6 plus 1 squared, is this equal to 49? 6 plus 1 is 7. 7 squared is 49, so that checks out as well. So I can be confident in my solutions to the equation. Example B, we have negative 2x plus 1 squared is equal to 81. And again, we'll apply the square root property. And notice we have this quantity squared equal to 81. So then the quantity, which in this case is negative 2x plus 1, would be plus or minus square root 81. So then negative 2x plus 1 is equal to plus or minus 9. Now again, I will break this up into two equations. Negative 2x plus 1 is negative 9, or negative 2x plus 1 is positive 9. Solving for x, so now we need to isolate the x. To isolate the x, I'll subtract 1 from both sides of each of the equations, yielding negative 2x is negative 10, or negative 2x is 8. And then I will divide both sides of each equation by negative 2, yielding x is 5, or x is negative 4. Let's check our work. First, I'll just do 5 first. So let's see. Negative 2 times 5 plus 1 squared, is this equal to 81? So that would give us negative 10 plus 1 squared, which is negative 9 squared, which is 81. So that checks out. And now we'll check negative 4. Negative 2 by negative 4 plus 1 quantity square, is this equal to 81? Negative 2 times negative 4 is 8. 8 plus 1 is 9. And 9 squared is 81. So that checks out as well, and I'm confident in my solutions to the equation. Exercise C, we have the quantity 3y minus 1 squared, subtract 4 is equal to 29. If we're going to apply the square root property, we must first isolate the squared quantity, which in this case is this 3y minus 1 squared. So we need to isolate that. To do that, we'll just add 4 to both sides. So now I have 3y minus 1 squared is equal to 33, and now I can apply the square root property. So then 3y minus 1 is equal to plus or minus square root of 33. Now the square root of 33 does not simplify nicely, so we'll just leave it alone because we were asked to give exact answers and approximate answers. So let's keep this in an exact form, and then later on we'll make approximations. Alright, so as I've done before, I'm going to break this up into 2 equations. 3y minus 1 is negative square root 33, or 3y minus 1 is positive square root 33. And now we'll solve each equation for y. I'll add 1 to both sides of each equation. Now be careful, that 1 is not a like term with the square root of 33. So what we often do is now write 3y is equal to 1 minus the square root of 33, or 3y is equal to 1 plus the square root of 33. Now we need to still solve for y, so I'll divide by 3 on both sides of the equation. And so then that gives us y is equal to 1 minus the square root of 33 over 3. Y is equal to 1 plus the square root of 33 over 3. So those are the exact answers. Let's make a note of that. These are exact. Now, using a calculator, I find that y is approximately 1 minus the square root of 33 over 3 is negative 1.58 approximately. And 1 plus the square root of 33 all over 3, y is approximately 2.25. Alright, and we'll check with those approximate values. Alright, so first, negative 1.58. So we'd have 3 times negative 1.58, subtract 1, square, subtract 4. Is this equal to 29? Now, it won't be exactly equal to because we've approximated. So let's see, on my calculator, 3 by negative 1.58, and I'll immediately add the 4. I'm sorry, not add 4, but subtract 1. So 3 times negative 1.58 minus 1 is approximately, it's negative 5.74. Squared, and subtract 4. Now negative 5.74 squared is 32.9476. Subtract 4 is 28.9476, which is approximately 29. So that checks out. And now with the other solution. 3 times 2.25 subtract 1 squared, subtract 4, is this equal to 29? 3 times 2.25 subtract 1 inside the quantity gives 5.75. So we have 5.75 square, subtract 4, and hopefully you see that's going to come very close to what we had before. It's 33.0625. Subtract 4, which is 29.0625, which is approximately 29. And so that checks out as well, and I'm confident in these solutions, whether exact or approximate.